As always, make sure you have a writing utensil and a calculator before getting started. Today we are going to continue looking at compound inequalities. What is a solution to an inequality? A solution is a value that will create a true statement. So for example, when we talk about a true statement, we are saying 4 equals 4. Or an example using an inequality is that 2 is less than 6. Or negative 5 is greater than negative 20. Those are just some examples of true statements. Today, we are going to determine whether or not a value is a solution to a given inequality. To check whether or not a value is a solution, we have to solve the inequality, graph its solution, and then plot the value to see if it falls in the solution region of the graph. So let's go ahead and do some examples. Number 1. Negative 3 is less than or equal to 2x plus 1, which is less than or equal to 7. We're going to solve the inequality and then graph it to see if the value 0 falls in the solution region. So let's go ahead and solve this equation. We're going to subtract 1 from all 3 sides of our inequality. Negative 3 minus 1 is negative 4, which is less than or equal to 2x, which is less than or equal to 6. Continue by dividing everything by 2. And we're given that negative 2 is less than or equal to x, which is less than or equal to 3. So here is our solution. This is an AND inequality, and we're going to go ahead and graph it. At negative 2, we have a closed dot. And at 3, we have a closed dot. And we want to plot all the answers in between. So if I look at this solution and I go ahead and plot it on this graph, you should notice that it's in that solution region. So when the question says, is x a solution to this inequality, we can say yes. So our answer here is yes. Number 2, 3x plus 5 is greater than 14, or 4 minus x is greater than or equal to 8. We want to know, does x or can x equal 3? So let's go ahead and test that out. We have to solve both inequalities. Subtract 5 from both sides. 3x is greater than or equal to 9. Oops, not or equal to. Just 3x is greater than 9. Divide both sides by 3. X is greater than 3. Now I'm going to solve the other inequality. Subtract 4 from both sides. We get negative x is greater than or equal to 4. And then we don't want a negative value, so we're going to divide both sides by negative 1. And remember, when we divide by that negative, we have to flip our inequality sign. So here is our answer. X is greater than 3 or less than or equal to negative 4. So if I graph that, 1, 2, 3, 4, here's negative 4. We have a closed dot on negative 4, and we want values less than negative 4. And we want 1, 2, 3, an open dot on 3, but we want values greater than 3. So here's our graph, and now we're going to go ahead and we're going to look at the value we're testing, which is 3. And if I look at it on my graph, notice it's an open dot. That means the value is not included as a solution. So is x equal 3 a solution? It is not. So our answer here is no. All right, is that number 2 again? Sure is. All right, well, I guess we'll have to fix that. But really, number 3. Okay, let's see. Let's change this pen. Okay, all right. So let's go ahead and continue to solve this problem. So I'm going to subtract 2 from all 3 sides of this inequality. And when we do that, we've got negative 3 is less than or equal to negative 1/2 x, which is less than or equal to 1. Now to get rid of the negative half, we're going to multiply all 3 sides by negative 2. So I'm going to multiply by negative 2 over here and over here. Now I don't really have room in the middle, so I'm just not going to show it there. So negative 2 times negative 3 is a positive 6, but we multiplied by a negative, so we flip our sign. X, flip our sign again because we multiplied by a negative, negative 2. So here's our solution, and we're going to go ahead and graph it. So we have negative 2, we have a closed dot. At 6, we have a closed dot. And we're going to show that our solution region is in between. And now we're going to take a look and see if x equals 2 falls on our graph. And it sure does. So can x equal 2 be a solution? It sure can. So we can say yes. All right, number 4. Let's go ahead and change my pen though, and my color. Okay, so we're going to subtract 3 from both sides, and we are left with 4x is greater than 12. Divide both sides by 4, and x is greater than 3. Now we're going to solve the other one. Subtract 4 from both sides. Negative 2x is greater than or equal to 4. Divide by a negative, so we're going to flip the sign. Less than or equal to negative 2. Again, this is an or, so we got to put that word back in there. And here's our answer. So we're going to go ahead and graph it. X is greater than 3. Here's 3 with an open dot. And then we're going to go to negative 2. And we have a closed dot on negative 2. We want values less than negative 2. All right, now let's take a look at that value. X equals negative 1. Well, negative 1 is right there. And that does not fall in our solution region. So our answer is no. All right, 2 more examples. Number 5. Let's just get my pen set up. Okay, number 5. First, we're going to subtract 2 from all 3 sides of our inequality. And negative 6 minus 2 is negative 8, which is less than 4x, which is less than 8. Now we're going to divide all 3 sides by 4. And when we do that, we're going to get negative 2 is less than x, which is less than 2. And here is our solution. So now let's graph it. We have an open dot on negative 2, an open dot on positive 2, and we're shading in between. Now we can check our value to see if it's a solution. X equals 1. If I look at where it is on my graph, it is in the shaded region, so I can say that yes, x equals 1 is a solution. All right, let's go ahead on to the next problem. Number 6. Okay, so we're going to solve these inequalities separately. Subtract 1 from both sides. Negative 1/2 x is greater than 4. Then we're going to multiply both sides by the reciprocal of negative 1/2, which is negative 2. So multiply both sides by negative 2. We're going to get x is less than, flip that sign, negative 8. And now we can go on to the other problem. Add 1 to both sides. You get 1/4 x is greater than 3. And here we're going to multiply by the reciprocal, which is 4. And when we do that, we get x is greater than 12. So our solution here is that x is less than -8 or it's greater than 12. So let's see what that looks like. 1, 2, 3, 4, 5, 6, 7, 8. Here is -8. We have an open dot and we're going this way. And over here we've got 12. Let's see if we have that on the graph. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to have to extend this. 10, 11, 12. It's an open dot and we're going that way. Okay, so we want to see, does -7 fall on the graph? So let's see, -7 would be right here. And it is not in the solution region. So our answer is no. Okay, let's go on to the word problem. The Special Grocery Club charges $20 a month to be a member, and you only pay $2 per item. Non-members pay $5 per item. So this is a little review. If you remember, we want to know what the cost for members, so cost for members, we want to know when that will be less than the cost for non-members. Cost for members, when will that be less than the cost for non-members? Alright, so we're going to set up our inequality. We know that the members pay $20 a month, and for each item they pay $2. We don't know how many items they're buying, so that's our variable. That's going to be less than the non-members, which pay $5 per item. So here's our inequality that we're going to go ahead and solve. We're going to subtract 2x from both sides, and when we do that, we get 20 is less than 3x, and then we're going to divide both sides by, whoops, don't know what I'm thinking. Let's get rid of that. We're not dividing by 20, we're going to be dividing both sides by 3. And when we do that, we get that x is greater than, oh goodness, 20 goes into 3, about, I want to say it's about 6.7 times. Okay, so first of all, I'm going to rewrite that as x is greater than 6.7. Remember, you always want your variable first. So the question is, how many items do you need to purchase to make being a member the best deal? Here they're saying that x has to be greater than 6. So we can say that you have to buy more than 6. So buy more than 6 items. Or you can buy 7 or more. So, or you can buy 7 or more. Because you can't buy part of an item. So that's why we can say more than 6, because that does not include 6 as a solution. That's telling us that you can say 7, 8, 9, 10, etc. Or you can buy 7 or more. In this example, they're including 7 as a solution. Okay, last problem. It costs $15 per person for admission to the OK Corral and $7 to park your car. What is the max number of people? So you have to be careful here because the variable is going to go with the cost of a person. So we've got 15x plus one vehicle, which is $7. We want to know how many people can we bring if we have $71. All right, so there's our inequality. Now we can solve it. Subtract 7 from both sides. 15x is less than or equal to 64. Divide both sides by 15. And x is less than or equal to, about 4 and change. So it's asking what's the maximum number of people we can bring. The max is 4 people.